Hello students, and welcome to your notes on lesson 6.1b, solving rational inequalities. Our learning target is I can solve rational inequalities by finding interval endpoints and testing the function. So we're going to get right into our examples. Example 1 says to solve the rational inequality and write your answer in interval notation. The first step for any of these problems is to set the inequality to 0. Okay, and this one we can see is already set with the inequality with a 0 on one side of the inequality. So after we do that, we're going to write as a single fraction. And we do see on the left side, we see a single fraction. Third step, we're going to set numerator and denominator equal to 0 and solve for endpoints. After we set equal to 0 and solve for endpoints, our fourth step will be to test intervals in the function. And I guess in step 3, I should have also said solve for endpoints / create intervals. Okay, so we're going to work through this. The first step is taken care of. We have the inequality set to 0. Second step is taken care of. This is written as a single fraction. We're ready for step 3, and that says to set the numerator and the denominator equal to 0. So that's going to be x minus 3 equals 0 and x plus 3 equals 0. I want us to also, in this step, make a note that the x minus 3 was from the numerator and the x plus 3 was from the denominator. Because what is going to happen when we create our intervals, the intervals from the denominator are going to get curvy brackets, whereas numerator are going to get square. Okay, so solving each of these, we get x equals 3 and x equals negative 3. So, we're going to create these intervals on a number line. So here's a number line, and my two endpoints are positive and negative 3. So if this is positive 3, negative 3 may be here. My intervals would consist of these 3 sections of the number line. The first section would go from negative infinity to negative 3. Negative 3 came from the denominator, so it gets a curvy bracket. Second interval is from negative 3 to 3. Positive 3 came from the numerator, so it's going to get a square bracket. And the third interval goes from 3 to infinity. And 3 came from the numerator and gets a square bracket. Now, I have just realized that I told you something wrong, so I'm going to fix it right away. If this symbol here had been greater than or equal to, I would have done this correctly, and I would have had square brackets here and here. But since it did not have the or equal to symbol, I should have used all curvy brackets, even with the numerator. So the numerator only gets square brackets if it's the greater than or equal to symbol. Sorry about that. Okay, so the numerator is going to get curvies here because it was not or equal to 0. Okay, sorry about that. Step 4, now we will test our intervals in the function. So what I want to do is choose a number, any number that falls in this interval between negative infinity and negative 3. I may choose to test negative 4. I'm going to use the easiest number to work with that I can think of. So if I substitute a negative 4 in for x in these two places in the function. Negative 4 minus 3 is negative 7. Negative 4 plus 3 is negative 1. And negative 7 divided by negative 1 is 7. I want to know, does this simplify to something true or false? Is 7 greater than 0? That's true. Therefore, this interval is accepted as part of the solution set. Next, we will test the interval from negative 3 to positive 3. So the easiest number in that interval to work with is 0. So what I will do is substitute a 0 in for both of these x's. So if I substitute a 0 for x here and a 0 for x here, 0 minus 3 is negative 3. 0 plus 3 is positive 3. Negative 3 divided by 3 is negative 1. Is that greater than 0? No, it is not. Therefore, this interval is rejected as part of the solution set. It is not contained in the solution. Last, go to your third interval. Choose any number that lies in the third interval. In the third interval, we say 3 to infinity, so I may substitute the number positive 4. 4 minus 3 is 1. 4 plus 3 is 7. That's 1/7. Is 1/7 greater than 0? Yes, it is. Therefore, 3 to infinity is included in the solution set. So my overall solution here is the interval negative infinity to negative 3 union with 3 to infinity. This is what you would type in as the answer. Example 2. Step 1 is to set the inequality equal to 0. So what I'm going to do is add x over x plus 3 to both sides. So that cancels it on the right side, giving me my 0. And that gives me 2 over x plus 3 plus x over x plus 3. And then I notice that I have common denominators. X plus 3 is the same denominator. So I can rewrite this as 2 plus x over x plus 3. Okay, so it's written as a single fraction. Now I'm going to set the numerator and the denominator equal to 0. 2 plus x equals 0. And x plus 3 equals 0. This gives me x equals negative 2 and x equals negative 3 as my interval endpoints. Noticing that the symbol is less than, I'm going to deal with all curvy brackets this time. So negative 3 may be here on the number line. Negative 2 would be there. My intervals include negative infinity to negative 3. Negative 3 to negative 2, and negative 2 to positive infinity. So last, I'm going to test a number from each interval into this function. So in the first interval, negative infinity to negative 3, I may test with negative 4. So 2 plus negative 4 over negative 4 plus 3 is my first substitution. So 2 plus negative 4 is negative 2, and negative 4 plus 3 is negative 1. Sorry. Let me fix that. Making a mess here. So I get negative 2 divided by negative 1 is less than 0, which is 2 is less than 0. Is that true or false? 2 is not less than 0, therefore we reject the first interval. Next, choose a number that falls in the second interval between negative 2 and negative 3. How about negative 2.5? So 2 plus negative 2.5 over negative 2.5 plus 3 is less than 0. 2 plus negative 2.5 is negative 0.5, and negative 2.5 plus 3 is positive 0.5. And negative divided by positive gives me negative 1 less than 0. That's true. So I will accept this as part of the solution set. Last, in the interval between -2 and infinity, I'll use 0. So substituting 2 plus 0 over 0 plus 3. 2 plus 0 is 2. 0 plus 3 is 3. 2/3 is not less than 0, so we reject that as part of the solution. So my solution only includes the interval -3 to -2. Example 3. This one again is not set equal to 0, so I'm going to begin by subtracting 2 over x minus 5 on both sides. Okay, so this gives me the fraction 2 over x plus 5 minus 2 over x minus 5. My second step is to simplify this to be one fraction. So x plus 5 and x minus 5 are not a common denominator. So what I have to do is create common denominators using multiplication. So on the left fraction, I'm going to multiply by x minus 5 over x minus 5, which I get from here. And on the right fraction, I'm going to multiply by x plus 5 over x plus 5, which I get from here. So, distributing, 2 times x is 2x, 2 times -5 is -10, over the quantity x minus 5 times x plus 5. Subtracting, distributive property, 2 times x is 2x, 2 times 5 is 10. Notice how I'm going to wrap the numerators up in parentheses. That's important here. Over the quantity x minus 5 times x plus 5 is greater than or equal to 0. Now I've created a common denominator, x minus 5 times x plus 5 in both fractions. So I can combine these, but those parentheses were important because I'm going to have to distribute the negative in. So I end up with 2x minus 2x, which cancels, and -10 minus 10 in the numerator. Well, -10 minus 10 is going to give me -20. Let me erase that. So we're going to get -20 in the numerator. And in the denominator, x minus 5 times x plus 5. Okay, this time my numerator, -20, has no variable. When there is no variable, you do not set the numerator equal to 0 in the next step. I do have, however, 2 factors in the denominator that contain x. I'm going to set x minus 5 equal to 0, and I'm also going to set x plus 5 equal to 0. Now these both come from the denominator. And when I look at my symbol here, it was a greater than or equal to symbol. If I had had an expression from the numerator, that would have indicated I would use a square bracket here. Since these are both from the denominator, I'm going to be using curly brackets. Okay, so this gives me 2 endpoints of 5 and -5. So on my number line, I have -5 and 5 as endpoints. That creates intervals from -infinity to -5, from -5 to 5, and from 5 to infinity. Last, we substitute, and what I'm going to use to substitute is numbers from the endpoint, and I'm going to substitute into this right here. So, I'll try substituting from this interval -6. So I'll get -20 over -6 minus 5 times -6 plus 5, greater than or equal to 0. So that's -20 over -11 times -1. Well, -11 times -1 is 11. So I end up with -20 elevenths. Is that greater than or equal to 0? No, that is not true. So we reject this first interval as part of the solution. From the next interval, I will substitute in a 0. So I'll get -20 over 0 minus 5, if I put a 0 here, I'll get negative 5. And 0 plus 5 will give me 5. So in the denominator, I'm going to get negative 25, and in the numerator, negative 20. Well, negative divided by negative gives me a positive, which reduces to 4/5. 4/5 is greater than 0, so we are going to accept this interval as part of our solution. Last, we'll substitute in the number 6. So if I substitute a 6 here, I'll get negative 20 over 1 and a 6 here times 11. Well, 1 times 11 is 11, so again we get negative 20 over 11. That is not greater than or equal to 0, so we're going to reject that interval. So here our solution set only includes the interval negative 5 to 5. This is what we would type in for our answer. Example 4, step 1, set it equal to 0. I'm going to subtract x over x plus 4 on both sides. That creates a 0. I have the fraction x plus 3 over x minus 5. Subtract x over x plus 4. I need a common denominator. Multiply the first one by x plus 4 over x plus 4. Multiply the second fraction by x minus 5 over x minus 5. In the numerator, on the first fraction, we FOIL. X squared plus 7x plus 12 over the quantity x plus 4 times x minus 5 minus, in the second one we're going to distribute, x times x is x squared minus 5x over the quantity x plus 4 times x minus 5 greater than 0. Okay. So now we can distribute our negative. So distributing our negative in, this becomes negative x squared and plus 5x. Combine the like terms. X squareds cancel. 7x plus 5x is 12x plus 12. All over x plus 4, x minus 5 greater than 0. Now, we're going to set both the numerator and the denominator equal to 0. Numerator, 12x plus 12 equals 0. I would use square brackets here if there were an or equal to symbol there, but since there is not, that's going to give us all curvy brackets. Okay. In the denominator, x plus 4 equals 0, and x minus 5 equals 0. So this is going to give me 3 interval endpoints this time. Subtract 12 on both sides. 12x equals negative 12. Divide by 12, I get x equals negative 1. Here I get x equals negative 4, and here I get x equals positive 5. So this time my number line gets just a little bit more complicated. My interval endpoints are negative 4, negative 1, and positive 5. So my intervals include negative infinity to negative 4, negative 4 to negative 1, negative 1 to 5, and 5 to infinity. And now I test the intervals. In the first interval, I'll substitute negative 5. So 12 times negative 5 plus 12 over negative 5 plus 4 times negative 5 minus 5. Okay, in my numerator, 12 times negative 5 plus 12 simplifies to be negative 48. And in my denominator, I get negative 1 times negative 10. So that's negative 48 over 10 which is clearly a negative answer, and that is not greater than 0. So I'm going to reject my first interval. Second interval, I'm going to try substituting in negative 2. So 12 times negative 2 plus 12 over negative 2 plus 4 times negative 2 minus 5. Okay, 12 times negative 2 plus 12 simplifies to be negative 12 over 2 times negative 7. That will be negative 12 divided by negative 14, which is going to give me a positive. A positive, 12 over 14, or 6/7, is greater than 0. So this is part of the solution set. Okay, next test the interval from between negative 1 and 5. That one contains the 0. That's an easy one to test. If I substitute in a 0 for x, I'm going to get 12 in the numerator. And in the denominator, I'm going to get 4 times negative 5, which is going to be 12 over negative 20, which is a negative, which is not greater than 0, so reject. Last, substitute in 6. Notice I'm not substituting in the end point. I'm never substituting the end point. I'm only substituting something that comes between 5 and infinity, not 5. Okay, so I'm going to substitute 6. So 12 times 6 plus 12 gives me a numerator of 84. And if I substitute 6 plus 4, I get 10. And 6 minus 5, I get 1. So I get 84 divided by 10 is greater than 0. That's positive. So yes, that's greater than 0. So I'm going to accept that as part of my solution. So my solution includes intervals from negative 4 to negative 1, union with interval from 5 to infinity. Now, have you noticed a pattern in the way the intervals are selected or accepted? Reject, accept, reject, accept. I'm not going to say that it's going to happen 100% of the time in mathematics, but it's almost going to happen all the time. It happens very often in that type of pattern. Question 5, we're going to set equal to 0 to begin. So I'm going to rewrite this as negative 1 over x squared minus 4 minus x over x squared minus 4 greater than or equal to 0. And this already contains a common denominator. That is the same denominator. So I can go ahead and write this as a single fraction. Negative 1 minus x over the single denominator x squared minus 4. Now, this denominator factors. So I'm going to factor that to write negative 1 minus x over x plus 2 times x minus 2 greater than or equal to 0. So now let's set the numerator equal to 0. This is numerator. And it's got a greater than or equal to symbol. So this is going to give me a square bracket at that end point. And the denominator, x plus 2 equals 0 and x minus 2 equals 0, those are going to give me curvy endpoints. So I get x equals negative 2, x equals positive 2, and solving here I get negative x equals positive 1 or x equals negative 1. My endpoints are negative 1, negative 2, and positive 2. So on my number line, here's 2, here's negative 1, and here is negative 2. So my intervals that I create are from negative infinity to negative 2. Negative 2 gets a curvy. From negative 2 to negative 1 gets a square. From negative 1 to positive 2 gets a curvy. And from 2 to infinity. And I'm going to test, just as I did all of the others. And I am not going to do that here. I'm going to leave that for you to do on your own. Substitute numbers from each interval and decide if you accept or reject each. The last example that I put on the video, it just looks a little different than the others, so I thought I would help you with starting it. I'm not going to work through the whole problem. But we're going to begin by setting it equal to 0. So 3x minus 9 over x plus 2 is less than 0. And then I need to create a single fraction. So I'm going to consider that 3x is a fraction that's over 1. So I'm going to multiply both the top and the bottom of this fraction by x plus 2 in order to create this common denominator. So I get, 3x times x is 3x squared. 3x times 2 is 6x. And then I have minus 9 all over x plus 2 times 1 is just x plus 2. This is all over a single fraction now. And honestly, if you consider this, I can factor 3x squared plus 6x minus 9. Well, I'm going to try to factor 3x squared plus 6x minus 9. Now, that would factor by AC, if it factors. So 3 times negative 9 is negative 27. So what factors of negative 27, that will give me a sum of 6, which would be 9 and negative 3? Yeah. So this should factor to 3x squared plus 9x minus 3x minus 9 over x plus 2 is less than 0. Now when I factor this, I got a group. So in my first group, there's a GCF of 3x. So factoring this out, I'll get 3x times the quantity x plus 3. In the second group, there's a GCF of negative 3. So if I factor out negative 3, that leaves me with x plus 3. Then if I finish factoring the numerator, x plus 3 is in common in both terms. So x plus 3 factors out, and I'm left with 3x minus 3. All over, don't forget your denominator, x plus 2. Once you get to this point, right here, you create your interval endpoints and test your intervals. So I will stop there. That one's probably the toughest one to get started with, simply because you had to create a common denominator out of something that didn't have a denominator. Excuse me. And you also had to factor it. So that one's probably the toughest one. But I hope this video helps you to get a good start on lesson 6.1b. Following this video, you will be ready to work on practicing for exam 3. So good luck, and hopefully you will get your lesson finished.